Hey, I'm so glad I caught you. You don't have to stop eating. I just wanted to talk to you a bit. Look, you know I love you, right? I think you're incredible, and frankly, I can't imagine my life without you. That said, I kind of feel like you haven't been pulling your weight around here. And I need you to help out more. You can't just expect me to do everything. Hear me out here. I've got an idea I think you might like. What do you think about 3D printing? Okay. Well, see, there's this thing called Octoprint. It's no secret that I'm a big fan of Octoprint. Ever since I discovered Gina Häußge's genius project to give the majority of desktop 3D printers remote access via the addition of a Raspberry Pi, I was hooked. It's an essential item in my 3D printing toolbox now, as is the Raspberry Pi 4. Here's the thing though. Raspberry Pis are powerful mini computers capable of so much more than just telling my 3D printer what to do. The incredible things that people have created with Pis could probably fill a whole corner of the internet. But I have never done more than give one a nice little case to live in. That is, until now. Did you really think I'd pass up the chance to get in way over my head making a life-size version of my favorite Adventure Time character? How dare you? This felt like the perfect opportunity to finally take the leap and do my first build involving electronics. The only issue was, I've never done anything like this before. We all gotta start somewhere though, right? Speaking of where to start, I probably should plan this out a bit. Since I'm a neurodiverse creative maker, my workflow might not look completely typical. I start by identifying my goals, which in this case was a BMO-shaped case for the Pi that could connect to my 3D printer and use Octoprint. I also wanted to be able to control Octoprint directly from BMO and utilize some of the physical buttons to issue commands to the printer. Of course, BMO wouldn't be BMO if he couldn't express himself a bit, so I also wanted to be able to trigger some facial animations to give him a voice. Other desired add-ons include posable limbs and a Pi camera that she can hold with her hands. Super simple and straightforward, right? To make this a little easier and a bit more bite-sized, for my own sanity if nothing else, I've chosen to break this project down into 3 sections: building and testing the electronics, designing and creating the case, and putting it all together with my programming of choice. This also makes it easier to turn this into 3 videos instead of it being one giant one. That said, welcome to BMO Octoprint Part 1, getting inside BMO's head. Now, let's actually make the thing. Obviously, there's a ton of tools and components necessary to the creation of an electronics project, and before starting this, I had little to none of it. Enter in Pimeroni, purveyors of unique kit, quality gear, and all things DIY electronics, based just next door to me over in the city of Sheffield here in the UK. They are one of the incredible sponsors for this project, and I couldn't be more excited to work with such an awesome company. Replete with new components, I was finally ready to start putting things together. To create BMO's face, I decided to use the Raspberry Pi 7-inch touchscreen display, which comes with an adapter board and mountings to attach the Pi right to the back of it. Not only would this allow me to access Octoprint without a computer, but without any additional components such as a keyboard and mouse. The ability to secure the Pi to the back of the display gave me a place to start with organizing the internal layout for BMO, which I started sketching out on the side. I was going to need to know how everything fit in her little body if I was going to design it to spec later. Thankfully, the Raspbian OS is super easy to install on a new Pi with the Raspberry Pi Imager software, and I was able to pretty much pop in the SD card and have a functional Pi with a working touchscreen with very little effort. My favorite amount of effort. Don't worry, the real effort, still yet to come. To let BMO have a voice, I knew speakers would be a necessity, as well as one of the more challenging parts for someone like me with 0 prior experience. I settled on the Adafruit stereo bonnet as my speaker amp because I knew it would still allow access to the GPIO pins for my buttons, but also give me my choice of speakers. The current model only needed a little bit of soldering to attach the screw terminals for the speakers, and an extra long header meant I'd have plenty of pin space for jumper leads. Another reason I chose the stereo bonnet is because I didn't want to be tied to the 3.5mm jack or Bluetooth speakers that would need an extra power source. There were quite a few options for speakers I could attach this way, which of course was both exciting and also overwhelming. I initially chose these oval 3-watt speakers, but ended up swapping them later for round 3-inch 5-watt speakers. This was just the warm-up round though. Now I had to actually make them work. Linux is rather new to me, but the Adafruit installation instructions were pretty easy to follow and understand, even for a newbie like myself. Of course, I still ran into issues of things just not working. To be fair, I was warned this might be harder than it seemed. And it was, but stubbornness is a quality I have in excess. For those of you following along at home who are curious, it turns out that the extra helper systemd script wasn't playing nice with the current version of Raspbian, and a fresh install without the helper script enabled got us moving again.
Front, left, front, right, front, left, front, right, front, left, front, right.
I'm not gonna lie, I really thought for a bit that I was done for. I am so relieved that installing Octoprint on Raspbian was both faster and easier than I was initially led to believe, entirely thanks to Gina's thorough instructions, which even a Linux beginner like myself could understand. I had the server up and running in almost no time at all. BMO's buttons were next on the agenda. I decided to do pull-up switches instead of pull-down switches, and knew I needed to arrange it on a breadboard to test before going any further. It may seem a bit silly, but I couldn't handle having a messy breadboard. What can I say? Aesthetics matter to me. I've not written much Python thus far in my nerdy little life, but I knew it would start being essential from here on out, not to mention pretty much the way to make sure my button switches were functional. It felt very satisfying to see my program responses on the screen when I pushed those little clicky boys. Now, I potentially could have stopped here and just mounted the breadboard inside BMO or moved things to a proto board, soldered them in place and been good to go. That would have been fine, but I wanted to take things to the next level. I wanted to give BMO his very own custom PCB, and PCBWay was awesome enough to help me do just that. I was overwhelmingly directed to KiCad as the software of choice for designing my PCB, and a great deal of reading gave me a huge leg up on how to go from knowing pretty much nothing about electrical schematics to feeling like I had some idea of where to start. That said, I would have been quickly lost and confused if it hadn't been for the saint-like patience and tremendous knowledge of Brody Fairhall. Not only did he handle my numerous inane questions like a champ, but gave me a complete rundown of how to use KiCad, which was extremely useful. With the electrical schematics complete, the real fun was finally able to begin. Once you assign all the correct footprints in the software for the components, KiCad ports over everything you need to start designing the actual PCB. Through Brody, I got to learn about things like vias, copper pores, and good trace placement. I loved how I felt able to apply artistic aesthetic while still meeting all the technical requirements for the board. Not to mention the use of vector files to add some actual art. In the end, I could hardly believe what I'd created. PCBWay made ordering the boards super easy, and it was so exciting to watch it make its journey through the fabrication stages in real time. It took a little bit of time, but look what's finally here. I am so excited. This is my first ever PCB. I've never done anything like this before. I've never held a PCB before, and I've certainly never gotten one fabricated especially for me. Thank you so much, PCBWay, for this. Let's get it open. Let's see what it looks like. I can only imagine what it's gonna be like. I have like an idea about how big it's supposed to be, but oh my gosh, I got goodies. Look at this. Look at this. Oh my gosh, this is so cute. I'm totally continuing on though. It looks like I've got shirt, but this, this, all right. Yeah, we got some other cool things, but this is what it's about. Oh my gosh. They're huge. Oh my God, but they're so cool. Look at this. Oh, I really wanna bust it open. This is definitely requires busting open. Yeah, let's Let's get one of these out as gently as possible. Oh, wow. Oh my gosh. Look at little BMO Octoprint and the GFA logo. Oh, wow, I am in love. I love this. Thank you, PCBY. This is amazing. I'm not gonna lie, I was super excited about getting to solder the components onto the PCB. My few experiences with soldering thus far have all felt really satisfying, and I was chomping at the bit to do more of it. I set up the PCB in such a way to try and keep the internals as clean and tidy as possible, so all the connection points are in the center of the board. The wires will get soldered directly to the breakout points on the Adafruit stereo bonnet, making everything nice and secure. Of course, I had to make sure what worked with the breadboard still functioned properly on the PCB, but everything's looking really good. And I mean, that's pretty much it for the internals. BMO Octoprint is set up with a brain, a face, a voice, and 7 functional inputs. That's not too bad for a start, wouldn't you say? Don't worry, I'm still planning on giving you a camera. Later, I promise. What? No, you don't need lasers to protect yourself from the cats. You're fine. All right, now you're just being ridiculous. I'm not giving you X-ray vision. Fine, I'll consider the guitar, okay? Good. I really do need to get back to work though. Behave yourself. Major electronic components complete. From here, I'll be able to start taking precise measurements and designing BMO Octoprint's body and limbs. You can fully expect multiple design iterations, test prints, and functionality experiments. But that's for the next video. This would be an excellent time to subscribe and hit the bell for notifications, as we're only just getting going on this build and there are still 2 chapters to come. Will I be able to pull off this big BMO upgrade? Will I manage to get everything put together without forgetting anything integral? Will BMO ever forgive me if I don't give him lasers? These are the questions, and you'd better stay tuned for the answers. If you're hoping to make your own BMO Octoprint as well, you're in luck, because not only will there be a full instructable release at the end of the project, but I'll be giving away a few of my custom PCBs to lucky fans. Follow me on social media to find out how to enter. Until next time, keep creating.